This is the 1 and 2 unit review that involves pre-algebra skills, equations, and inequalities. It's to prepare you for your Keystone testing. So number 1, we could just simply put it in our calculators. 12 times the quantity 3, second, square root button, 16, get out of there first, then close a parenthesis, raised to the negative second. Okay, you'll get, okay, I don't know what that is. None of those are 0.83. So we go to the math button. Fraction's already highlighted. I want to make this a fraction. So your answer is A. Or what you could have done is simplify as you went. Oops. This is to the positive first, so it stays. This is negative, so it goes. And we have 1/12. Either way is fine. Next, we're solving the inequality, meaning we have to remove everything that's near y. So we remove a positive 3 first from all sides. We are left with 12 is less than negative 4y is less than 24. When I divide everything by a negative 4, I'm going to get negative 3, but be careful. The signs are going to switch. Okay, y is less than negative 3. These aren't negatives. I can cancel them out. Which one has y is less than 3? That's A. Let's make sure y is greater than negative 6. Yep, it works. Number 3 is tricky. It says, which of the following is true for all values of x? Meaning, if I put any x value in here, which one will make it true? So I try usually 3 types of scenarios. If I put in positive numbers, will it work? If I put in negative numbers, will this hold true? And when I put in 0. So if I put 0 into all of these, I believe they all work. So when I say that I'm okay with 0 cubed, yeah, that's true. Yes, that's true. If I put 0 in here and 0 in here, yes, that's true. If I put 0 in here, and I put 0 in here, yeah, that's going to be true. So 0 works for all of them. Let's go down here, or off to the side. If I put a positive number in here, is this going to be true? Okay, let's put a positive number that's decently large. So like 3. If I cube 3, is this true? If I square 3, yeah, it's true. If I put 3 in here, 6. 6 squared is 36. If I put 3 in here, 9 times 3, yes, that's true. If I put 3 in here, that's 927. If I substitute 3 in here, that's 27. Oh, that doesn't work. Okay, so it's not B. Let's try it in here. 3, if I put 3 in here, I get 1. 3 times 1 is 3. If I put 3 in here, I get 9. 27 minus 2 is, that's not going to work. So it doesn't work for positives here or here. Okay, so we have C and D. Let's put in a negative number. If I put in negative 3, I get negative 6 squared, which is 36. If I put negative 3 in here, I get positive 9, I get 27. That's true. If I put a negative 3 in here, I get negative 27. And if I put a negative in here, I get 9. That's not true. This is true, and this is true. Your answer is C. It works for all of them. Okay? That one's a little intense. Yes, you have to do a bunch of work for it. You have to plug in positive numbers and see if the inequalities are true. Okay, number 4, it says students in a 9th grade class measured their heights, h in centimeters. The height of the tallest student was 72. The height of the shortest student was 54. What inequality represents the range of heights? Well, your height would be in between these, but if the tallest student was 72, maybe you're that student. Or maybe you're the shortest student, so you can also be equal to. That means we can get rid of A and B. We have equal to. I have to be less than 72. I'm less than 54 here. I'm less than 72 here. My answer is D. It's just flipped backwards. It's the same thing. Okay, number 5. A baseball team has $3,000 to spend on supplies. The team spent $210 on a new bat and then $4 each for baseballs. Use the inequality, okay, to determine the number of baseballs the teams can purchase. So if we subtract 210 from both sides, from 3,000, we're going to get 2790. We're going to divide both sides by 4. We're going to get 697.5. Okay, well, I can't buy 0.5 of a baseball, so I have to round down, actually, because I can't spend more than I have. And that's the highest you can go. It says or less. So the team can only purchase 697 baseballs? No. The minimum number of baseballs is 697? No. That's the highest. So it would be the maximum. Okay. Tim's score for the first 5 games played. Okay, so the first game he gets this. The second game he gets this. Fourth and fifth. Tim's scores follow a pattern. Which expression can be used to determine the scores he played in a video game? Well, if you notice every time, you're going up by how many? 44. So does anyone have a rate of change of 44, like 44x? Or 44, okay. That has 44n. That has 44n. That will have, okay, so it's not this one. All right. So we also have to see if I plug in a 1 or if I plug in a 2, I should get the outputs of each of these. So let's try with 44n plus 3452. If I plug in 1, do I get 3452? Well, obviously not, because you're adding 44 to it. So it's not A. If I plug in 1, do I get a result of 3452? Well, we have 3408 plus 1 times 44. No, that means your score was 149,000. That is not 3452. So it must be the last one. I start 3408 plus 44 times 1. I will get 3408 plus 44. Yeah, I get 3452. So when I plug in 1, I get a 3452. So this is an equation that represents the pattern of Tim's scores. On the back, if y equals 5x, what is the value of y over x? Well, y represents 5x over x, which equals 5. This right here, y cannot equal 0, is just reminding you. If you put 0 in the denominator, it won't work. We're just letting you know that. Here, Jeff's restaurant sells pizzas. P is a plain pizza. That's the $8. An additional charge for each topping, $1.50. What does $1.50 represent? The number of toppings? No. The cost of a pizza? No. The additional cost of each topping? Yes. It literally says it. Okay. Mr. Smith wrote 9 less in comparison to than 6 times a number. The whole thing is less than 16. Well, if you see less thans, you should automatically know the greater ones are probably not going to work. 9 less than. If you said you were 10 years less than somebody, you would subtract 10 to find the age. So you have to remove it from something. That's B. The chart below shows an expression evaluated for different values of x. When you substitute in 1, you get 7. When you substitute in 2, you get 11. 6 is 47. And when you substitute in 7, you get 61. These are all prime numbers. Josiah concluded that for all positive values of x, x squared plus x plus 5 produces a prime number. Which value of x serves as a counterexample, meaning it makes the statement false? To prove Josiah's conclusion is false. So if I plug in a 16 into that equation, do I get a prime number? Using my calculator, I get 277. Yep, that's a prime number. So that would not be a counterexample. If I substitute in 5, what do I get? 5 times 5 plus 5 plus 5. 35. Is that a prime number? No. No, so this is our counterexample. It goes against the pattern. Mike's solution to an equation is shown below. Which statement is true? Mike's solution is correct. He made a mistake in step 1. He made a mistake in step 4, or a mistake in step 5. Well, let's go through the problem and see what happened. He was given this. He has to distribute, so he'll get 7n plus 70. Yep, he does. So it's not step 1. He then combines like terms. Yes. He then subtracts 70. Yes. And he gets 54. Well, what's 134 minus 70? This should be 64. So yes, in step 4, Mike made a mistake. That's called error analysis. You're analyzing the errors. Number 12. Some ordered pairs for a linear function are given below. Which of the following equations was used to generate the table? Well, we know slope is change in y over the change in x. So my y is my change. That's what this delta, this triangle means. Change in y over change in x. Well, I changed in y was positive 4 over the change in x, which is 2. My slope, therefore, is 2. So my answer is either A or B. Well, if I plug in 6 or a 4, which one gives me their output? Let's just go with 6. It doesn't matter which one you pick. If I plug in 6 here, I get 12 minus 1, which is 11. Yeah, so that's my answer. Let's make sure. 2 times 6 plus 1, that's 13. That's not 13. So yes, my answer is B. Number 13, one of the steps Jamie used to solve an equation is shown below. Well, here we see she just simplified, she added. Which statement describes the procedure Jamie used in the step to identify the property? Jamie added to eliminate the parentheses. This procedure is the associative. Jamie added to eliminate the parentheses. This procedure is distributive. Well, she didn't distribute. Jamie multiplied. No, she didn't multiply. No, she didn't multiply. So it is the associative property. They associate with specific groups. So yeah, we grouped them together. All right. Solve the following equation. Well, we have to simplify before we solve. So I need to distribute this 3 to the 6 and the 2 as well. We always deal with the variables first, not the numbers. These will cancel and we're left with negative 6 equals negative 6. It's easier for us to see. Okay, is that true? Yeah, that's a true statement. Because it's a true statement, your solution is all real numbers. If it was no solution, it would be false. And if you're not sure, this is how you check. If you're like, well, maybe it's all real numbers, put in any number you want. And if it works, then that's your solution. Here, we're going to distribute again. We're going to get 15x minus 9. But then don't forget about the negative 3x plus 9. I'm going to simplify before I solve and get a 12x. And the negative 9 and 9 disappear. Students usually freeze up at this point and just say no solution. But are you doing what you're supposed to be doing? Do you have x by itself? No, you need to divide both sides. 0 divided by 12 is 0. If you're not sure, check your work. Substitute 0 in. If I put 0 in, I get 0 minus 3, which is negative 3, times 3, which is negative 9. 0 times negative 3, that disappears. And this is 9 and a negative 9. Yeah. All right, here, absolute value bars need to be by themselves. So I have to remove this positive 5. I get negative absolute value of x plus 4 is less than negative 8. I have to have the absolute value bars by themselves so I know what the actual distance is. The distance, we have to divide by a negative, so we flip the sign, is greater than 8. If my distance is greater than the number 8, then I'm the numbers 9, 10, 11, 12, and so forth. So x plus 4 can be greater than the number 8. But if I'm a distance greater than 8 this way, I'm the numbers negative 9 and so on, which is actually less than negative 8. So that's why we flip the sign. When you solve for both sides, you'll get 4 and negative 12. That's your solution. Okay, this is all review from the first quarter. Some of you might be rusty on it. Some of you might have not done as well. But that's okay. This is why we're reviewing. And you're just going to do your best. All right, when I divide these to get them into decimals, I need something that's going to be between 0.54 and 0.58. Well, pi is obviously not that because that's 3.14. This is way bigger than those. Square root of 8 is 2.28. All right, so it must be this one. Let's try it. 0.2916 gives me 0.54. Well, this one's actually, is it 0.54? It's actually 0.5384. So yes, it is A. Okay, now we have the two open-ended questions that are left. It says George has $10 in his pocket for lunch. If a burger and fries cost $7.50 and each item is 50 cents, how many additional items can be ordered to stay within this budget? They want you to write an equality and illustrate the number of additional items that can be ordered to stay within the budget. Well, if there's $10 in his pocket, he can spend $10 or he can spend less than it. He can't spend more. They wanted you to write an inequality, not an equation. They say that your burger and fries are $7.50 plus then 50 cents for each additional item you want. When you go ahead and solve, you're like, okay, I have $10. I spent $7.50. Then I divide by 0.5. So I have 5 items. So how many additional items can be ordered? 5 items or less, because we said inequality. Here it says 3 Smith children are ages, they're consecutive odd integers. So maybe the kids are 3 years old, 5 years old, and 7. Consecutive means right in a row, and they're odd. The sum of their ages is 45. Well, it's not that. Maybe it's 5, 7, 9. Add it up to 45. This is guessing and checking and not the most effective. We know that no matter what, we don't know the first age of the kid. But the next kid, second kid, is going to be 2 spaces away, no matter what, from the first kid. And then the last kid is going to be 4 spaces away from the first number. So that's how we're going to define the ages that we don't know. We know it equals 45. You're going to then combine like terms. Oops, I didn't ask that there. It says solve the equation that illustrates. I should have been writing it down here. Well, if that's the case on your keystone, then you erase it and you rewrite it. That was an equation to get us started, and now we're simplifying and solving. Well, your answer is not 13. It says, what's the sister's age? Well, 13 plus 2 is 15. 13 plus 4 is 17. Okay, so your test is just like this, so make sure you know what you're doing. Okay, when you take your test, though, you're going to have an answer sheet just like this. I want you to fill it out and just submit this and submit your open-ended questions. Okay, this is for virtual students. If you're not a virtual student, you don't need to do that.